All right, we're going to start here with number 30 and continue on. First thing you got to realize is that one of the options of these problems is that the segments do not form a triangle at all. So you want to always say that the sum of two sides has to be greater than the third side. 5 plus 9, bigger than 13. 13 and 8, 13 and 5, bigger than 9. And 9 and 13 bigger than 5, the sum of those two. So that there is a triangle existing here. So the fact that choice A is there, that one's not possible now. So if we're going to do an obtuse triangle, acute triangle, or a right triangle, what I try to teach is to use this situation here. Always use your c squared first. You don't have to, but if you do, then when you can fill in this box with a less than, it becomes acute. Greater than becomes obtuse, and obviously equal to becomes a right triangle. So doing that for this problem, 13 squared is actually 169. And then we're going to compare that to the sum of the squares of 5 and 9. So that's 25 plus 81, and I think you can quickly see here that 169 is going to be greater than those, so since it's greater than, this is going to be an obtuse triangle. Alright, given three segment lengths here, I can quickly, hopefully you can quickly see that the answer here would be A, because 17 plus 25 is not even greater than 80. Now when I say that, I'm not checking for obtuse, right, or acute. All I'm doing is realizing that no triangle exists. And then moving along to number 32, a triangle actually does exist here, and when I use this value as my c squared value, what we're going to end up seeing is that, oh wait, I'm not going to do this because I recognize that this is the 9, 40, 41. And if I do that and recognize that it's times 9 each time, well, if it's a 9, 40, 41, then I can see that it actually forms a right triangle. All right, now moving along here, try to make this a little bit bigger here. To number 33, we're going to start practicing some of our trigonometry. All right, so solving for each of the following problems, we're always going to 2 decimal places for the sides, and angles are going to go to the nearest minute. So following here, this is a really important lesson here. If you're struggling with trig, I really hope you watch this carefully because it should help you on all the other problems. Now first of all, I recognize that theta here can actually be solved without use of any trigonometry. So theta is equal to 90 minus 26. So we're going to get that very easily using no trig of 64 degrees. Okay, now that's one of the three things that I need to find. A, C, and theta. I found theta. I don't want to use theta in my calculations because I've really been trying to ask you guys to use the given values only. So, here, let me back that up a second. So actually, if I grab my highlighter here and we look at this problem, I am given 26 degrees. I am given 8, and then let's try to find A here. I can't use Pythagorean Theorem, so I'm going to use this trigonometry with those values. So according to the 26 degrees, I have the opposite leg, and I have the adjacent leg. So I have opposite and adjacent, opposite and adjacent, so that would be SOHCAHTOA, UNOA. So here we go. So tangent of 26 is equal to opposite 8 over adjacent, which is A. So what we're going to do here is multiply both sides by A and divide both sides by tangent of 26, and essentially, like we've been seeing in class, these two just switch places. So the A is going to be equal to 8 divided by tangent of 26. Now I'm going to go over to the calculator over here, and this is very important that from your home screen you go to your settings. So go to 5 settings and then 2 settings and then 1 general, and see, this is no good. My answers are not going to come out right if my calculator is in radian mode. So I have to change that to degree mode, and then I don't want to just click OK. I want to click Make Default if I can. Okay, so now my calculator is set up. So when I go to a calculator page, what I want to do is I want to click 8 divided by tangent of 26. Now I personally kind of like to look at fraction like so. So I'm going to say 8, go down. You can see the key sequence here. Whoops, that didn't type in. So 8 on top, and then on the bottom I'm going to type in tangent of 26. So you can slow these down if you need to, but tangent of 26, and then when I hit enter, I am getting, it's a little bit smaller, let me see this, see if I can make this window a little bit bigger. There we go, it's a little bit better. So 16.4024, so once again rounding to 2 decimal places, A is going to be 16.40. Alright, so we found our A value, and that was one of our goals. Okay, next I'm going to take this red highlighter, and again we were given 26, given 8, and then now we're finding C. So again, you don't want to use Pythagorean Theorem here because you might have made a mistake finding A. So we're going to show how to use trigonometry to find C. Alright, so according to the 26, we have opposite and now hypotenuse. So opposite and hypotenuse, so that is sine. So the sine of 26 equals 8 over C. And likewise, these are going to switch places. So C is equal to 8 divided by sine of 26. So when I go to my calculator, just to show you different ways, of course you could just type in 8 divided by, and then trig, I'm going to have to go up here, sine of 26, and then when I hit enter on that, I am getting my value, and we should say approximately, I should have said that a minute ago because we rounded, but C is approximately 18 point, it looks like 25. So I have found the items that they asked me for, and this is basically the scenario of where we have one side given to us and one angle given to us. Alright, so we're going to go through a different scenario here, and this is the one where we have to find the angle measures. Now, straight up Pythagorean theorem, no trig, 11 squared plus 17 squared is equal to C squared. Alright, well, I should have mentioned this, but there's no family, no principle of the reduced right triangle or special, so just Pythagorean theorem. Okay, so what we're going to do here is we're actually going to get 410 equals C squared, and then when we take the square root of both sides, we're going to see C is, well, let's do that. So the square root of 410 delete here. And that's coming out to approximately 20.25, and that is rounded once again. So there's our C value just by Pythagorean theorem. Okay, but what we want to do is we want to try to find theta here. So give my highlighter back. Okay, if I highlight this and this and this, those are what I'm looking at. I'm looking at the theta, I'm looking at the opposite, and I'm looking at the adjacent. So looking at the opposite and adjacent, that's going to be tangent. Oops, sorry. So that's going to be the tangent of theta, which is equal to 17 over 11. So 17 over 11 is the ratio. The calculator, remember, in our trig tables, we know the ratio of a right triangle. We have all of the angles stored, so we're going to ask the calculator for theta. And how do we ask the calculator for theta? We're going to say the inverse tangent of 17 over 11. Okay? Now be careful, that could get a little triggy. Get it? Triggy. Okay, we'll continue here. Theta is approximately the inverse tangent of 17 over 11. So I'm going to go over here and I'm going to hit trig and tangent inverse, and then I'm going to type in 17 divided by 11 and hit enter. And I have my angle, but remember we want to convert these to DMS. Some of you have been finding a fast way to do this. In the book, you could go to this third tab here, and a lot of people have liked this because it'll stay on here every time then once you find it. It's actually this conversion button. So I do want to click that, and it says, do you want to convert your answer? Yes, I do, and I'm going to type in DMS because I want to convert it to degrees, minutes, and seconds. Alright, so theta is approximately here. This is going to be 50